everyone, this is Ashok here, and this video we are going to talk about Python programming essentials for data science. I'm going to use Jupyter Notebook for this session, and if you are not aware of Jupyter, I request you to check back another video in Module 1 which talks about installation of Jupyter and a few commands on Jupyter. Alright, I'm going to touch the Python related to data science, which means I'm not going into core Python or the Python programming language as such in an extensive manner. It's basically Python for data science. Let's get started. I'll name this file as Python Essentials for data science. Okay. There are many data types in Python. I would target the data types which are more relevant for data science. So let's start with Boolean. Boolean data type in Python takes two inputs, true or false. True or false. Okay, let me make this cell markdown. Okay, and I'll just give data types in Python and make it this. I'll make it list. Okay, and integer data types are integers from negative and positive. It does not have a decimal value, and if you simply type in integers, it's by default it's signed integer, which means it can take negative and positive whole numbers, basically integers. I'm not going to talk about the bits and the files, the storage space. It's not relevant for us. You also have unsigned integers, and I leave it because we don't really work with them that much. Float or decimals, and typically float has a precision based on the kind of float you're using. So I'll give you an example here. Integers are to 10, minus 10, 19, whatever. Float 252 and minus 6.5. These are the kind of data which we call it as float. We also have complex data which has two components, something like, let's say, 3 plus J4 or I4. Okay, don't worry too much about it. When it is necessary, in a use case, we will talk about the complex data type. String or collection of characters. So strings are, yeah, I can say this is a string. I am want to be a data scientist. So this is your string. And time is an object, and this is one of the object. We don't call it as, it's not a core data type as such, but we extensively use this time object. It can have time and date. That's good enough for our purpose. So let's explore one by one in a very brief way. I would say a is equal to 3 and print a, so I'm expecting 3. So if you want to know what kind of variable this a is, it's visible, that's integer. We use a simple command type. In a parenthesis, you put variable a. Run the command by pressing Shift Enter. That's the way you run it in Jupyter Notebook. It says integer. Okay. If you give 4.2, for example, you're expecting a float. Okay. If you give true or false, you're expecting a boolean. Okay. And you can also experiment other things like string. I would say the strings are always in double quotes or single quotes. I would say, hey there, and this is a string. It's basically str is a string. Okay, that's about the basic ones. Let's move on to time. In Python, to execute an object or import a library, we use a command called as import, I-M-P-O-R-T, I-M-P-O-R-T, import, and import date time. Date time is the package or library. Okay, so this will, okay, new module called date time. Oh, sorry, I would say date, not data. Data, date time. All right, and this library contains many um, uh, built-in objects and functions. We are not going to go through all these things. If you want to know the database, the complete documentation of it, you can simply type in Python date time, and it takes you to your documentation of Python. The site is docs.python.org, and library and datetime object. It has a very extensive details about what are the objects inside datetime, sub packages, functions, attributes, etc. Okay. In this tutorial, I'm going to touch a few of the things we generally use in data science analysis. Let's talk about today's date. So there is a function in datetime and there is a date module inside it, sub package, and then you can say today. All right, and this will give you today's time, today's date. Today is 19th of March 2018 year. All right, so this is March, this is 19 is a day, and this is a year. All right, great, very nice. So how do you know? I mean, if you want a little helper in Jupyter, you can use tab button. Press a dot and press tab button in your left hand side in your keyboard, and that will pop up all the objects, functions, and attributes which are available in your datetime or the object which is we are going to looking at. You can simply type in enter to get it. Again, another dot. Just press one character so that you don't show the entire list, but the things which starts with today or T. That's easy way of doing. Moving forward in the tutorials, I'm going to use this little helper in Jupyter notebook, which helps me to actually display stuff so I don't have this typing errors and spelling mistakes. Okay? All right, great. We got the date. What about time? I want to know the time format. Okay, and for that we have a package in datetime dot datetime. There's another datetime sub package. Please be very careful here. Datetime is your primary library or the main package, and datetime is a sub package. Just like date over here, datetime here is a sub package. Inside datetime, there is a function called as now. This will give you time now along with all the other details. So this is year, this is your month, this is your day, this is your hours in 24-hour format, which is 2 o'clock in the afternoon. I'm in Bangalore, India. 41 minutes, 34 seconds, and then microseconds, milliseconds, and microseconds. All right, fantastic. So this is very useful function. Right. Sometimes you don't want to call like date time and date time. It looks very ugly. I want to import the date time sub package as well. So how can I do it? I can use a simple command in Python called from datetime, which is my main package. I'm importing another datetime, which is a sub package. If I do this, okay, I don't have to say datetime. I would simply say datetime.now, and that will give me the answer. What I have done now, I have imported this datetime, which is sub package, from the datetime, which is a main package, using this from datetime import datetime. You will do more of these things, then you will get more comfortable with it. I can also do here. See, if I execute this datetime command, sorry, date today command without datetime, okay, I'm just going to delete this. It will throw an error saying, I don't know what you mean by date, because date is not visible to my session now, right? I have only downloaded datetime, but the date sub package is inside my datetime. It only understands if I say this. This is the only way, okay. datetime dot date and today. Okay, import datetime. All right, so sorry, I don't know why it threw that up. So, but I don't want to like type in this one. So I can simply say my previous command from datetime. I import date, right? If I do that, I can simply say date today. That will work. It was showing error here, but here it worked because I have imported the sub module or the sub package date from the main package datetime using a syntax from datetime import date. Okay, I instead to spend more time over here because this is really we have to understand this small way of importing stuff. Moving forward with the datetime more, if I want to um assign a date or create a date uh, from a date, I can say, let's say my birth date or some date. Let's say date. Let's say my daughter birthday, my daughter birthday, my daughter birthday is equal to. I want to give a date. There's a small function called date. Okay, and I can simply say date, and I can pass on the details. So I would say 2009 July and 14. Okay, by it's showing a red, I can just give a direct number. So this will create an object as a date with whatever I've given. So this is my daughter's birthday. Okay, and that's the way of creating a date directly from a date you have. And I want to calculate what is the difference between how many days my daughter's age in days. I can do a simple numerical calculation by saying, sorry, print my today. Okay, I'll take today minus my daughter's birthday. That's a variable I have defined over there. That gives me days. So 3,170 days is my daughter's number of days in age. All right, just to show you how we can do the calculation with the days. There are many other variation you can actually do, and one of the another important function in date is time delta. Let's say I want to add 100 days from today and see what would be the date. Okay, I can do that using 100 day, or I'll just give a name variable 100 day. Okay, for today I simply use date dot today. If I do plus 100, that doesn't work. It will gonna throw error because 100 is an integer and this is a date object. So I have to convert this 100 into 100 days. Then I can add it. To do that simple conversion, we use a tiny little function called time delta. That's from the datetime package. And I say time delta. Literally means the difference in time. And inside this, you can give many variables. You can check out the complete documentation. You can simply type this in the Google, and you will find the documentation with all the parameters in it. I highly recommend you to do the experiment, right? So time delta, and you can just look into all the variations of it. So let's come back to our tutorial. Time delta, I can simply say days is equal to 100, and I will print my variable. So if I add 100 days to today, so the date I'm going to get is June 2018, sorry, 27th of June 2018. And you can also subtract. So this tiny little function time delta is really helpful in terms of date manipulation, addition, subtraction of the dates. And there are many other options as well. Okay. All right, that's all about the date. Moving forward, when it comes to mathematical operators, let me take a markdown and write math operators. In Python, more or less, it's very intuitive and pretty standard mathematical operations. For example, if I say 10 plus 4, it's addition, I'm supposed to get 14. And 10 minus 4, 6. And 10 multiplication is denoted as asterisk or a star. It's like any other programming language. You get a 40 and print 10. If you put 2 stars, which is exponential, it's like 10 to the power of 4. You're supposed to get 10,000 in this case, which is visible over there. And if I say 10 divided by 4, how much you get? You get a 2.5. If I say 10 modulus is represented by a percentage symbol, which actually gives you a reminder, okay? And you get a 2 over here. So modulus operator, we call as modulus operator, returns reminder. If you are a programmer, you should be aware of this because most of the programming languages use a similar stuff. Okay, then the next topic is typecasting. Typecasting, okay. Well, 4 is an integer, or like, and when I put 4.0, it's a float. When I put true, it's a boolean. When I put something as a string, that's my name, it's a string. Okay, great. Right. So what happens if I say 4 plus 3.5? So I'm adding an integer and a float. What do you expect? I mean, there are two different data types, right? So am I going to get an integer or am I going to float? Well, as in any other programming language, it always auto typecast to the higher data type. So in our case, integer and float is a higher data type. It has more precision, right? So automatically your 4 gets upgraded into float, and then you and you add 4 plus 3.5, you get a 7.5. Okay, any operations you do, for example, I want to say 2 into 2.5, so I'm going to get 5.0 here. Just notice it is not 5, it's 5.0. It's a float we are getting it because this 2 is being upgraded into float and then the multiplication happens. What if I add something to a string, something like this? That looks very weird. I would say 3 times. Oh, I want to do this. But that's an integer and this is a string. Do you really think it's going to work? Try it. No, it doesn't. It's going to throw you an error saying that, hey, you know what? I don't know what you're trying to do. Integer adding with a string doesn't make any sense. But you really want to add this integer to a string, I can typecast forcibly or a manual typecasting. I will say string and then add it. This is what you're expecting 3 times. Okay. So this particular thing is called as forced typecasting or a manual typecasting. You're forcing a 3 integer to become a string. I can also do a forced typecasting for all the other types as well. For example, when I say integer of 4.6, what you expect to get? 4.6 is a float. When you downgrade to integer, you will lose 0.6. So you will be getting 4. Okay. If I typecast integer, does it work? Yeah, it does. See, a string 3 has become integer 3. So you can play around it. I can say float of 4 or 5 or 6. It becomes 6.0. Okay. So these functions, string and integer and the float, or force typecasting. Okay, hope it makes sense. Moving ahead with logical operators. Take a markdown cell and say logical operators. All right. Python has pretty much very user-friendly logical operators. So if I say print, logical operators are comparing. If I say 5 greater than 3, where greater than this thing is a logical operator. Okay, I'm comparing 5 and saying I'm writing a condition saying is 5 greater than 3? Yes or no? True, because obviously 5 is greater than 3. If I execute, I should be getting a true. If I say 5 greater than or equal to 3, yeah, it still get true. If I say greater than or equal to 5, yes, because we have equal to here, so this should be true as well. What if I say 5 or 5 is less than 3? You're gonna get a false. So the operators here is greater than, I'll convert it to a markdown. This is for greater than and less than and greater than or equal to, greater than or equal to, and less than or equal to. And we have inequality operator, which is not equal to, that we write it as exclamation mark and then an is equal. It's not equal to, right? We have two is equal to say equal to. Equal to. Remember, when you put one is equal to, then it is an assignment operators. For example, if I just do a equal to 3, I'm asking Python to assign a 3 value to a. So when I type in a, you get a 3. But here I'm trying to use a logical operator. So I'm saying is equal to. So is equal to is double equal to. If you put a single equal to, then it becomes an assignment operator. Okay. And these are your logical operators. Okay. No, it doesn't look good here like this. So what do? I'll just make them a small nice list. Okay. Some of the formatting has taken place. That still doesn't work. Apologies. Oh, you know what? I'm going to leave it as raw. At least the raw will not touch any of the code, so I can leave it as it is. So some way the raw cell is useful. I'm going to change it to raw. Don't do any changes. However it is, leave it. Oh, it works great. I'll take another raw cell, which means don't process my data. Let's talk about, I'll make it markdown. Comparison operators. Comparison operators in Python, and this I'll make it raw cell. So we have and or, and or. These are two comparison operators. Okay. So how do you compare? Let's say we are saying I'm comparing two conditions: 5 greater than 3 and 6 less than 3. What do you expect? 5 greater than 3, true. 6 less than 3 isn't true, it's false. So if when you get true and false in AND, it will give you false. So I will just write a small statement here. Comparison operators always compare two conditions. For AND, if both are true, then result true. All other cases are false. For or, if both are false, then result, okay, then result is false. Nope, sorry. All other cases are true. So what does this mean? It basically means if I say, I'm going to copy it just to show this. Let's talk about AND. So 6 greater than 3, 5 greater than 3, 6 greater than 3, true, true, and result is true. Okay, this is true, true condition, true and true. It comes to the next one, we have a true and false. So I would say this is true and this is false. And this one, I'm going to create something like false and true. So this I'll make it 5 less than 3 is false. 6 greater than 3 is true. Okay, and the last one, false and false. So I'll say 5 less than 3, which is false, and 6 less than 3, which is false. You run this one, you'll see only the first condition, true and true, is true. All the rest conditions or possibilities are false. That's what this means. If both are true, the result is true. All the other cases are false. You can do the same thing for or. You can do it by yourself. I'm not going to explain that. Okay, moving forward, let's go to the conditional statements. Conditional statements. There are many conditional statements in Python. So we are going to focus on only few of the things, and especially if condition. Okay. If you might be already familiar, if you have a bit of background in programming, but even if you're not, this is pretty simple example. So if actually have three components, if, else, if, we call it as ALF, else if, and else. This is one compound statement. Let's write a quick example. X is equal to 3 or 2. And I say if x is greater than 0, and the syntax is you write a condition and then you put a colon. Okay. Come to the next line. You observe that it automatically indents. So this is required. This particular indentation is required. If you don't do it, Python will throw an error. Okay. If x is greater than 0, I'm going to print it is as positive number. Yeah, of course, if it's greater than 0, it's positive. Okay. And then I press the backspace to go back, and I use else if, ELSF. Else if I'll say x is equal to 0, which means a conditional statement to test if x is equal to 0. I'll print it's 0. All right, great. And all the other conditions, there are only one condition left. If it is not greater than 0, if it is not equal to 0, it must be less than 0. I'm not going to write the condition here. Simply say else, which means all the rest of the conditions. And I'll say print negative. That's all. This is a simple if-else condition. Okay. When you run this cell, x being the 2, you expect invalid syntax. No, that's not what I expected. Or you have to put a colon here. My apologies. So colon is very important. Okay, you get a positive. If you put a 0 here, you get a 0. If you put a 1 or any negative numbers like -8, you get negative. What's happening? It takes the f value. The if condition checks this condition first. And the syntax is you write a condition and I put a colon. And then the next statement, if this condition is true, then it executes the next statement, which is print positive. If it is false, in this case it is false, it will skip this one and come to the next else if, and it will check the else if statement again. X is equal to 2? No, it's minus 8, not equal to 2. So this is also false. So it will skip this one and come to the last part, which is else. So everything else in any other condition, it's going to print negative. If I put a 0, it checks here, it fails, so it will skip this statement. It come here, it will check, it's success, it will print this 0 and goes away. It will not execute the else anymore. So in the if else block, only one block will be executed, either this block or this block or this block. Okay? And you can write multiple commands in this block. It's not just one command, you can write multiple commands. Oh, my apologies. Yeah, you can leave it like that, it's not gonna hurt you. So I have just written 3 different zeros just to show that you can actually run multiple commands and this entire block will be executed and then it will be coming out of the compound loop. It will come here then. This is your simple if statement. And most of our data science work in SQL programming, if statement is pretty good for conditional statement. There are other ways of doing it, but we will see it in an advanced Python programming. For now, if condition is pretty good. All right, so for this is part 1, and there are a lot of other things in terms of different types of objects we use in data science. We will deal it in the next video, in part 2. Hope it's useful. Thanks for watching. I'll see you in another video.